Ladies and gentlemen, welcome to another episode of the Engineering Tech Show. And here are your hosts, Goshi King and Joe Green.
Dear architects.
Enough with the glass.
That's a very good response, Joe. How are you today?
I'm doing very well. How are you, Goshi?
I'm pretty good. I'm excited about this podcast.
Me too.
The thing is that in our industry, especially in the consulting industry, as you know, we sort of indirectly or directly work for the architects.
We do.
So we can't be really harsh on them.
No.
Because you can't
Can't bite the hand that feeds you.
That's
too
right.
much.
I was just going to say that.
Yeah.
You can't bite the hand that feeds you.
Maybe nibble a little bit, but you still have to get some more food.
Yeah, but let's see, in our industry, it's so laid back. We kind of have this, most of the time, a relationship with the architect that we can work together to, help each other out in different aspects.
Mm-hmm.
Like I know for mechanical systems, oftentimes, architects, they don't know our stuff, and we don't necessarily know their stuff. But what happens is that they start a building, they do the architecture, and then MEP comes in, and then MEP says, we need this, and then it sometimes becomes a challenge for them to allocate, programming space for just MEP mechanical electrical systems, IT and MDF type of stuff.
You think that over the years they would learn that all these utilities need space. But
Well, yeah, but,
it
it's
doesn't seem to catch on.
sometimes, when you're in prime real estate,
Mm-hmm.
it hurts.
Yeah.
Because they're under the pressure of the owners that says, I need this much programming for whatever it is. It could be a theater, it could be a hotel, because, you've seen hotels, as small they like to keep their rooms,
Oh, yeah.
for, maximizing the profit, right?
Floor space is, it's a
Yeah.
price.
I think in some economics it's called operation research to maximize the use of space,
Yeah.
But I think we right off the bat we started with our title of this episode. We called it "Dear Architects."
Enough with the glass.
Enough with the class. Why?
Well, from our perspective, we have to deal with the glass. We have to heat and cool all of the effects that excess glass imposes on the space. We have to make sure people are going to be comfortable, like sitting close to a giant panel of glass, that they're not going to be too hot, too cold.
And I completely get that. What's happening is that your glass, right? Now, with the modern architectural system, right, or architectural design, and by modern I mean more like contemporary. What did I made a note to myself. This is how I was going to describe it, because word modern is sort of relative to the times that people talk about it, right? So if this podcast was 20 years ago, modern probably meant something different.
Mm-hmm.
I was on the GSA website where I kind of found a whole bunch of styles of building,
Yeah.
and that's why I picked up my notebook, because there were so many of them, and I was like, I can't remember all these. So I made notes to myself, but one thing I did not find in there is that today is the modern curtain wall building style. And do you mind going into, Joe, telling our audience what is a curtain wall
Sure.
and what is that style?
Curtain wall, or I guess you might also hear it, storefront glazing systems, basically is giant expanses of glass. And so instead of a little, like a punch window, kind of cutout window, which is most homes would have, little like 3x4 or 3x5 window, these are floor to ceiling.
Yes,
glazing
corner to
walls.
corner.
Yeah.
Yep. And all you see is a thin framing,
Yeah.
in between, the glass itself.
Mm-hmm. Yeah, it needs a little structure to support it, but even that, architects are trying to get away with it. So you almost have it's probably tricky, but from the floor all the way to the next floor above, just glass.
I mean, there are high-rise buildings. So if our audience would like to just go to DuckDuckGo on a Firefox or a safer browser without using Google at all. See, I made a pitch for
Yeah.
freedom right there. And if they just looked up modern curtain wall buildings, they'll see all styles. They'll see, buildings that are 4 or 5 story tall to high rises, 40 some plus stories and beyond. And they'd see that all they see is this building that's glass,
Yeah.
right? Come in different buildings have different tint to the glass, the glazing. And it also sometimes is, different shapes and forms, right? So what you do is you look at them, and they look very, very fancy. I've got a little audio problem here. Let me see if
difficulties.
Technical. It's pretty cool that you can tell, like, I can't hear myself anymore. What's going on?
Yeah, I could all of a sudden I hear you more. I guess not through the microphones, but
Yeah. It's different.
Yeah.
It's so much cleaner, crisp coming through these headsets. Other than because when it's not coming from there, then I'm hearing probably other things.
Get a lot of distraction.
Like the fan that's in this laptop, and
it is a pretty high fan too.
And the snoring of my cat somewhere or purring somewhere. Anyway, so back to the curtain wall problem.
Yeah.
Well, they look beautiful. There is no question about it. This modern architecture that's all glass, whether it's a daytime or a nighttime, when the lights are on inside, and lighting consultants and electrical engineers put quite a bit of thought into the lighting that goes into it, and it has some benefits like daylight savings in terms of electricity use. If you have so much curtain on your exterior wall, and there's no solid wall at all, it's just glass, light just pours right in.
Yeah.
But that's not the only thing that pours in, is it?
No. A lot of heat pours in, and heat can pour out as well.
Yeah, he can pour out as well.
Even in our office with our main south-facing glazing, we don't have curtain wall. We have kind of punch windows. But most of the time, people have the shades closed on that because it's too much sun. They get glare on their computer screens and just unwanted light. So even though we do have a lot of windows, most of the time our lights are on. So it's kind of a funny thing to see, I think.
We may need a new plug here.
Yep.
It's still recording fine, though. We may not be able to hear each other.
We'll have to go in blind.
That's embarrassing, guys, that we have a little technical problem in the middle of our podcast. I'll probably have to cut this off. It's more editing for me.
And show bloopers.
Yeah.
That's all.
Actually, you know what? We'll take them out and put them in the end.
Yeah.
That'll be fun. All right. So, let's talk about that, Joe. That in curtain wall in the summer, we have a lot of solar gain.
Mm-hmm.
You want to touch a little bit on that? What does that mean for the owners, for the heating and cooling? Not heating, but cooling.
Yeah.
Since we're only talking summer right now.
So in the summer, obviously, the object would be to stay cool. You're typically provide air conditioning. You have to battle with higher outside temperatures, but now also you have to battle with any solar gain from the sun. So that's kind of just the sun's radiation making its way through your glass, hitting surfaces, heating up the surfaces, and then that heat radiates out to your space. So it's kind of like if you're sitting right by a window in the summertime, you'll get that sun on you. You're going to feel pretty hot, not just the heat radiating from outside through your window to you, but you get that direct solar onto you. And that's, I guess, sort of off subject. Like, that's why a lot of, art windows, they will put them on the north side of it, because on the north, at least in our northern hemisphere, you don't get direct solar. You will have diffuse solar, which is just you get that light naturally kind of diffuses in. So it's a more consistent light. It's not going to be as subject to glare or to, let's say in the summertime, you get your low sunset angles where the sun comes directly in on you, and it can be kind of annoying. It gets right in your eyes or right in your computer screen. And
You
that-
could have some glare and reflecting from
yeah.
different types of. I have an experience where there was a lot of curtain wall in a biosafety lab,
Mm.
and what was happening was that the after the building was built, the countertops of the certain labs, in certain labs were somewhat like they have a glossy, shiny white finish. And I forget it was almost like the top surface of the counter was glass, but then underneath it was all white. And then the sun would hit a certain, like from southwest side, it would hit that, and it would create this glare in people's eyes, and they were very uncomfortable with it. So they had to go and add shades, internal shades.
Mm.
Added some money to the project, but they had to do that. And in a minute we'll get into some of the solutions that we can offer to our architect friends and even owners to see how you can avoid certain obvious, or take some obvious measures to minimize the impact of solar gain.
Have you been to Chicago before? Like downtown, the riverfront area?
I have not.
So I know when you mentioned the different architectural styles, so, you go to downtown Boston, the whatever wharf area, it's all like glass towers. And I know in Chicago you get a lot of buildings that were probably in the early 1900s, mid 1900s built, where they didn't have this, I guess, glass technology. And it's a lot of like stone buildings. They'll have windows, a lot of windows, but no vast curtain walls or no vast like expanses of glazing. It's kind of a much different architecture than what we would have in modern buildings, especially like modern cities where, it's glass towers. And it's, I don't know, I think it's interesting to hope that those designers account for extra glass radiating and reflecting off of their neighbor buildings onto you. So in those cases, you could have like a north wall, and maybe that building to your north is going to reflect solar right in on you. So you might think that you could have a nice, safe, minimum solar gain spot, but you could get hit by...
Reflective, yeah.
Yeah.
Wow, that's an interesting point. I never really thought of that. Wow, you're so clever, Joe.
I learned from my mistakes.
Yeah, that's good. That's good quality to have. So, in the passing, I'd mentioned that I was on the GSA website. Boo to that, because who wants to be on the government website? But that's what showed up.
Mm-hmm.
Poor choice, DuckDuckGo. But I saw this different building styles, and I always, I was always fascinated with some of the older architecture that had a lot of detail, like Masonic detail to it. Not like secret society Masonic, but like masonry,
Yeah.
like art, that trim work and stuff like that. And I went through, and I did not know exactly what that style is called. I've called it many different things over years, or probably incorrectly almost all the time. But here is what some of the ones that I found were called like federal style. It was somewhat boring to me. It looked like early 1700s or maybe like 1600s. But right beyond that, the next style that came about was Greek. And the Greek style you can see in many buildings. Some like, for example, if you go to like Lincoln Memorial in Washington D.C. and those like tall pillars,
Mm-hmm.
that's kind of an indication of a Greek style. And then that was followed by the style called Italianate, and then Romanesque.
Romanesque.
Thanks. Romanesque. That's what I meant to say. And Renaissance? No.
Yeah.
Yeah. After that was the Second Empire. I don't know where they grabbed this name, but the Second Empire, that sounded pretty good, or looked pretty decent. But my favorite one came after that, which is so fascinating. And I have a couple of examples if people wanted to see what that was, but it was called Beaux Art Classicalism.
How do you spell that?
Beaux. Beaux Art Classicalism. Or Classicism. I think it's Classicism.
Classicism.
Yeah, my scribble I can't read. And then after that was like the neoclassical classicism. Then colonial, and then Spanish colonial, which is interesting. And then came the Art Deco and modern.
What did you like about the Beaux Art classicism?
Well, it's the style.
Okay.
So the detail, like the there were so many bends and corners, and like around the windows were not. There were a lot of windows, but they were maybe somewhat like more of a residential type style windows, and then around them, what's the masonry and the millwork that's around these windows. It's just fascinating, and I kind of want to talk about one of them. I think it was called like the Eisenhower Executive Office Building. If somebody wants to look at that, I think that would indicate, or you can just type in in your Google and say Beaux Art, classicism, style buildings, and I'm sure some really good stuff will pop up. And then mid-century modernism. But I think what we're talking is even beyond that, because I think the mid-century modernism is also something that stopped somewhere about 20 years ago. So this new style, the curtain wall is in. Like I can't tell you how many times I've, and I'll give you a couple examples, like recent examples in a minute that I've been working with the architects and I've seen that over and over, like this whole concept. There are a few schools that we're working on. They have these lobbies that are massive and tall, and all there is just, if you look at the building, it's just glass. It's this massive glass, beautiful looking, but nonetheless. But what I, one of one of my favorites, and I'll ask you that in a minute. Maybe you can answer me in a follow up. But I like, yes, it's not. I'm not proud to say this, but the Capitol building in Washington D.C. I think that's a beautiful architecture. Old town homes or town halls in different cities like Philadelphia and whatnot. That architecture, right? And then
like the stones.
Yes. Yeah, like the entire building.
Like a massive stoneworks.
Really. Yeah, like the town hall building in Philadelphia is bloody beautiful. It's gorgeous. What happened to the architecture? Why are we not making those anymore? Is it that the masonry is too expensive? I mean, now we have FAW technology. We can make things from machines that, all you do is use all this millwork is pre-done. You don't have to do it from hand anymore. It could be like very light materials, like FAW, whatever, and then you just plop it in, nail it in, or glue it in, or however it works. I can't really glue it outside, but you get my point. Like just like tiling, right?
Yeah.
You can use that as tiling. Cathedrals. I mean, some of the Catholic cathedrals or otherwise cathedrals that I used to live in, like around Baltimore area, not in the city but outside, like in suburbs. And St. Paul Street in Baltimore has this church. I can't tell you, man. It's like every time I drove by there, oftentimes I would stop, just stop, step out of my car, and just look at it. It was a gorgeous piece of architecture in 1800s.
We used to, when I was a family, when I was a kid, we would go up to Montreal and check out the Notre Dame Cathedral up there.
I've been there.
It's amazing. It's a beautiful building. Well,
so you say that, and I'm getting off tangent here, but that building, the Notre Dame, it's inside.
Yeah.
That's so much more than the outside. Yes, outside is very beautiful, and it's old, and it's ancient, and it's got, it's architecture. But, man, inside, it's unbelievable.
Especially the old buildings, when you go in, they might have, like, nice marble floors or something like that. And you're right, too. Every little piece of woodwork, every corner, you can tell that some person probably spent hours just shaping it and etching little fine details into all of it. It was the work it would take is years and years, I'm sure, of some master stonecutter or mason just to get it right. It's impressive. Definitely details that aren't necessary. I guess with like glass buildings, you just pop up glass and you're done.
Yeah. Well, I mean, it's not that simple either. I mean, the structural changes quite a bit, and but the money.
Yeah.
The curtain walls are expensive. I mean, they're not cheap. They're not only expensive to buy, and then again, we're gonna get into the types of the glass that often is used, and like single pane is never used. It's usually double pane, triple pane glass that is used, and then sometimes they have like this gas between the glass, but then there is something new that's emerging. It's not widely adopted yet, but we'll touch base on the vacuum.
Yeah.
Right. But what's your favorite style
of buildings?
Yeah.
Boy, I would have to say the probably mid 1900 buildings, where it would be more stonework, more stonework.
More stonework.
'Cause
Yeah.
I do think that you can make some pretty beautiful buildings, and just admiring the work that would have gone into it.
Yeah.
I know, I guess do it now, I guess maybe it's more with smaller buildings, but ones that can combine like stone and woodwork, especially once you go inside. And I like to see some woodwork around. Kind of makes me feel like I'm not in some institution. Like you still get that kind of a connection to nature in a way, and it keeps it a little bit more varied.
Yeah.
Instead of just, going to some, like a school building, and you just get your bland corridors
Yeah.
and bland classrooms.
Mm-hmm.
I find that very boring. So when they can add some like life into it, it's enjoyable.
Yeah. With the contemporary furniture style too, that's another podcast another time. But with contemporary furniture styles, that is now somewhat often paired with your curtain wall type of buildings, right? Like the modern buildings. I don't know. I'm not a big fan of that either. Maybe it's
the furniture?
Yeah.
Well, I mean, like this chair I'm in, I would consider it sort of a modern-y, but it's comfortable. But some modern furniture is, it might look fashionable, but it's probably as comfortable as sitting on like a wood board.
Yeah. Well, so here's the thing, right? Like, I guess it all boils down to personal preference and what owner wants and what the client wants, right? And architect caters to them, or architects convince them that, like, look, you're gonna pay, this chair that I'm sitting on was $700-800 just for one chair because of the reclining features, whereas the one you're sitting on is from IKEA and that's $150, right? So there is that. There is economics of it, right? You're comfortable in that chair, right?
Yeah.
I like that chair, but I can't really. Maybe if I'm reading one of these books, right, it's fine.
It makes me want to slouch back and take a nap.
Is it that comfortable? I didn't. Anyway.
Yeah, I'll take it from you.
That's
a good point.
You're welcome anytime, Joe.
Architects I guess we're more interested in comfort, and architects can be more interested in the aesthetics of it. So
yeah,
while we would not be the first ones to sacrifice comfort for aesthetics, I think architects would be most likely the exact opposite, and maybe not even consider the comfort and the implications.
Well, the thing about the architects is, so I don't know if you recall, there is a very famous novel, and it's about architects, and Fountainhead.
Yeah.
And then in Fountainhead, there was a part where, the hero or whatnot of the movie, I don't remember it's been so long. I actually have it right in here somewhere. We probably should look that up. But the person when he was in college and was going through some interviews, he was brought to a board that was interviewing him, and there was a conversation about Promenade. There was some building. Did I say it right?
I think so.
Promenade. Yeah, I think they pronounce it Promenade. Actually, the reason why? Because I didn't read it. I have the copy. I listened to it in audio.
Okay.
And the narrator of the audio said Promenade. So the Promenade building, the architects of the time were obsessed with it. But then this gentleman, I wasn't really a gentleman at all later on in the novel, but that's beside the point. He and his office, who he was working for, was just completely against that style. They just wanted to build simple buildings, So anyway, so it's sometimes when there is a trend, when everybody is on some bandwagon, it's very hard to get off the bandwagon. Sometimes it just doesn't make sense, but then they don't care because that's what the client wants, and that's what the architects specializes in, and that's what they do.
Yeah.
But that has implications. So we were talking about in the summer, as how in the summer the solar gain can increase heat inside your building, and now you have to cool it,
to
right?
take care of that heat.
And I want to before I get into the cooling part of that, like what's the impact of these tall buildings in the winter? Let's talk about what happens to the heating and ventilation system. Ventilation is easy. You're bringing outside air based on how many people are occupying the building and what's the square footage. It doesn't necessarily do any cooling for you, right? It can at times if it's significant, and then you don't have a design day where it's 90 degree out, maybe it's 72 degrees out, and you may have just enough air coming in to cool an office, right? So say if you're dropping 100 cubic feet per minute of air into a room, right? You have possibly 100 square foot room. It's just that you don't have to turn on an air conditioning. Just your ventilation air alone is probably cooling it. This is hypothetical, and don't hold me to 100 CFM, but I'm just giving an example. And if you have solar gain, right, sun is pouring in, it's 95 degrees, 100 degree out, if you're in somewhere south, then you've got a problem. You've got to cool this building, right?
You do.
And an engineer has to account for that. An engineer has to say, hey, 99% of this wall is glass, right? Curtain wall, that's essentially it, right? 95 to 100% essentially is assumed. And you're getting all that, you're getting the solar gain right into that space. You've got to now treat it as if this is outside.
Yeah.
Right? Sun's baking on you. You've got to cool this place. And so to cool this place, you're going to need air conditioning. And that air conditioning is going to increase in size based on how low quality of glass that's used on the wall. So the shading coefficient is what you're looking for. And higher the shading coefficient, more cooling you're going to need. So what happens is a design engineer, a mechanical engineer can go back to the architect and say, hey, listen, you've given me a U value of this glass that is this much, and you've given me a shading coefficient that is this much. And I am seeing, in one instance where I was working on this lobby that was all curtain wall, I was seeing 5 CFM, or cubic feet per minute, of air required to cool this space on a design day per square foot. Okay, 5 CFM per square foot. That's massive. That's too much, right? And if they were just using smaller windows, then based on the size of the window, the same type of glass, you could reduce the amount of heat gain that you have in the space proportionally. Or when they're talking to the architect, you could say, hey, listen, you've got to use a better glass here, right? And they can come back and they say, all right, our shading coefficients change from, for example, I know my audience is probably not going to understand this, but say for 0.35, it went to 0.24, right? And that's 1/3 less than what it was before. And so that 5, or for the ease, let's just say it was 3 CFM, now it's come down to 2 CFM per square foot, okay? That changes things. And if that changes, and then most likely you're going to do that in all the rooms, right? You're not going to change. The architect's not going to just change the window for one room. They're going to change the entire system. Typically, that's how it works. And so now, all of a sudden, just by improving the shading coefficient of the glass, right, a U value of the glass, you've reduced your cooling load that was required to 2/3. Okay? You've reduced the reduction of the energy that was required to cool the space is now reduced by 1/3, right? Just by improving that, right? And that I speak that from experience. I've seen that in a couple of projects where I was talking to the architect and the glass selection was not great, but then when they realized, like, okay, this is going to require too many fan coils or a bigger air handler or more horsepower in the air handler, because now you need more air to move from the space, it changed things, right? And so when they improved the glass, we were able to, as a mechanical engineer, reduce the size of that equipment to something reasonable. And then also depends on where you are. And here in Northeast, what's reasonable, in my opinion, is anywhere between 2 CFM per square foot to 3 CFM per square foot for spaces that have high occupancy. For example, lobbies, right? Like function lobbies, and like, you know, event spaces, right? I see that's pretty standard.
Mm-hmm.
If you can stay around 2 CFM per square foot, that you've hit the, you know, somewhat
Sweet
idealistic sweet spot, right? It's obviously it's better if it's less, because like again, we all talk about being green and everything, right? And green energy and well, you can create all the green energy you want, but then if you're gonna start doubling your usage, then what happens to you're counterproductive there.
Yeah.
Right. So similarly, like in a classroom, in an office, a small office where there's 1 or 2 people, it should be around 1 CFM per square foot, no more. So if you're seeing more than that, then that means your envelope is not great.
I think especially in the days where we have acoustical consultants in all the projects, if you have to supply excess airflow for just cooling comfort reasons only, I mean, you're going to have much larger kind of utility systems. Your ductwork is going to be larger. Just
It's going to double, right?
Maintain it
Yeah.
to some reasonable sound.
Mm-hmm.
Not to mention, if you're dumping a lot of air on someone, they're not going to be comfortable. Or if it's so much air and they're moving your papers around, they're not going to be a very happy customer.
That's
I think
right.
There's a lot of kind of
A lot goes
comfort.
into.
Yeah,
Mhm.
and it's easy to overlook that, or just to let, I don't know, if architects get carried away, there can be a lot of repercussions later on with just that person's comfort inside.
I mean, the equipment size. So for example, if you have, and I'll give you an example of a church,
Mhm.
right, where there was this lobby which was 25 foot tall, and it was south facing and west facing. So glass was south and west. So essentially, it was in the Northeast here. One of the tips that we would like to give architects is that if you have to add curtain walls and a lot of glass, try not doing that on south side or
Mhm.
southwest side, right? West side also is somewhat same problem, but a little less, right? And then east and north is better
It's better.
comparatively. You know, still is a problem, but it's better. And so that lobby, what had happened was when we did our load calculations, and a load calculation, for the people who don't know, is a calculation, a mathematical calculation that is done to determine how much cooling and heating the space is going to require based on the outside conditions throughout the year.
Mhm.
And when we calculated that, we came across massive amount of cooling requirement, and it turned out to be 8,000 CFM. Cubic feet per minute, which is CFM, was required for that lobby. If it did not have the curtain wall the way they had, it should have been no more than 2,000 to 3,000, because it was maybe 4,000 CFM. You know why? Because it's 2,000. Like I said earlier, like it was a 2,000 square feet of space, roughly about 1,900. So based on our sweet spot, which is 2 CFM per square foot, it should have been around 4,000 or less, right? That would have been ideal. But now, because they had so much glazing on, glass on 2 sides from floor to the roof, right? So much solar gain was applied to this space that the cooling load went up insane.
Mhm.
So to overcome that, you literally have doubled the size of equipment. What does that mean? What that means is that you have this air handler that's already a size of a bus that sits on the roof, right? That weighs, say, 6,000 pounds, right? Not including the dunnage that goes with it, right? The support curb, that's probably another 500-600 pounds. You have doubled it. So you've doubled it. That means the bus grows. I don't know how much, but it grows quite a bit, right? Because it's doubled.
It's almost a double decker.
Almost
now.
double decker, right? But
Yeah.
It's not proportional always like that.
Mhm.
It goes by, if it has energy recovery wheel, then it grows differently. If it doesn't have energy recovery wheel, things are different, right? Whether the rule of thumb is whatever your CFM is, you divide that by 500, and there's like a standard size that you can pick on certain manufacturers.
Mm-hmm.
Anyway, Train being one, and so I just gave Train a plug without even realizing it. So what does that mean? That's not just it though. Now the structural engineer has to look at the size of that, right, and they say, okay, before you gave me 6,000 pounds, now you've given me 10,000 pounds, and now I've got to beef up my structure to support it, right? It's a trickle effect, Joe.
Mm-hmm.
It increases the size of your air handler. It increases the power required to run those fans in horsepower, right? Because you have a supply fan, you have an exhaust fan, you have heating coil, cooling coil, energy recovery wheel, you've got controls, everything is growing, right? Then you have structural guy who's got to look at it and say, all right, I got to make sure that this is my steel, my structure can support the weight of this thing so that my building's not going to collapse.
Let's hope so.
Right? And then the ductwork doubled. The
Yes,
ductwork,
especially if you have larger steel and then trying to fit larger ductwork in there.
right?
It sounds like that would be just a coordination issue.
That's right. So now the architect may have to look at, and the engineers have to look at the ceiling space, right? Before, the architect's probably trying to keep 11-foot ceilings in most spaces, and there was maybe 12 or 14 inches between the bottom of the steel and the ceiling, and that's where you were running ductwork. Now that needs to be doubled.
Mm-hmm.
So they have to drop the ceiling to 8 foot, or they have to raise the
I'm
building.
sure architects probably love to drop their ceilings.
No, and
Probably very accommodated there, right?
You're being funny there,
Yes.
Joe. You're so awesome. No, architects don't like that. Owners don't like that, right? And mechanical engineers in particular are almost always faced with this dilemma that ductwork does not fit above the ceiling. So easy solutions are to not have that much curtain wall, and if you do have curtain wall, maybe use spandrel.
Yeah.
Change.
Spandrel is something, when I came to understand what it is, it kind of sort of blew my mind that, spandrel is purely aesthetics from the outside.
Yeah.
I think for people who don't know, it's basically you take a piece of glass and then you build a wall behind it.
Yeah.
So it's like, from the outside it looks like glass, but from the inside it's a wall.
Yeah.
And it's for me to get why someone would do that, except for the aesthetics of it, it does
Aesthetics.
not make any sense.
It's strictly aesthetics,
Yeah.
because and it's sometimes it's a compromise. Maybe maybe what someday what happened was that some architect wanted to use curtain wall full from right to left, top to bottom, right? And the mechanical engineer says, you're increase my air handler size double. This is the implication. Structural engineer all those spiel that I just went through, right?
Mhm.
Everything doubled. And the architect says, I've got an idea. I'm going to put a little plate behind it, and then I'm going to insulate it behind, and then we're going to have a wall. And then and this is exactly what happened to me, Joe. The 5 CFM per square foot in this church turned into, so what they did is on both sides, the south side and the west side, they changed the curtain wall. They turned half of it into a spandrel. And my CFM per square foot, which was 4.8 or 4.9 CFM per square foot, came down to 2.5. Literally, right? Now I don't have the solar gain anymore, half of it anyway. So now I've gone back to my original size.
I think another, point of that too, once you get your size gone down, your mechanical equipment is going to be selected for a more reasonable load, and you're not selecting it for like 1 or 2 hours out of the year. So your mechanical equipment itself will just run more efficiently. It's not going to be, it can kind of run at a more efficient load for most of the year instead of peaking for an hour or two and then running sort of inefficiently or cycling more often. So I think it can be a lot of long-term benefits by kind of a more right sizing.
Yeah, comparatively, it has advantages.
Mm-hmm.
The distribution becomes easy for a mechanical engineer to provide, and you don't have as much in a 2,000 square foot. You're not moving too much air that creates some sort of drafty conditions. You often go into like hospital lobbies or other places, or and other places, regardless of where, if it's not designed correctly, people feel like it's cold in here, right? And you get goosebumps, and it may be like 95 degrees outside, but then inside you're freezing.
Yeah.
And oftentimes it's because it's not designed correctly, both architecturally and mechanically. And architecturally, because there were some certain assumptions that were made that you have so much glass and then it's going to have so much solar gain, and they size their equipment bigger, right? And then all that air that's got to move, it's not about the velocity anymore, it's the volume now. And then that much massive volume, even though it may be moving at 50 feet per minute, which is ideal, right? It's going to create this chill effect. It's going to turn it into a freezer.
Yeah. Now, I enjoy nice cold spaces in the summer, but not everyone does.
Not everyone does. I mean, in our own office, Joe, throughout the summer, I've seen people, not you and me, but some other people have been wearing sweaters.
And that's, I know, I think like typically females have lower metabolism, so they will, they'll wear sweaters in the hottest of summer days, and sometimes they'll have sweaters only for summer to wear indoors, and then when they go outside they take it off because it's warm. But it is I think when you create environments that someone has to wear a sweater in the summertime indoors, something is not right.
So it becomes challenging. And then let's jump right into the winter. So all that glass, what does that do in the winter? Problem with there's this concept called downdraft, and a convection that happens at the glass. So in the winter, if it's very cold outside and you're trying to maintain 68, 70 degrees indoors, if you were to stand next to a curtain wall that has no heat treatment, you would feel that there's a cool air that's moving downwards on you, right? And it has this chill effect. And so bigger the glass, obviously, taller the glass, more problematic that becomes. And mechanical engineers understand that, or I hope they do, and they try to fix that problem by one of the two ways. They either wash the glass with air, hotter air, to offset that, right? But again, that coolness is already in, so they have to heat it. So there is an energy waste because of so much glass that it was added. Reasonable glass is fine. It's not unexpected that buildings are not going to have windows, otherwise they'll look like prisons, right? So aesthetically it's important. Everybody understands that. Everybody wants to work in a beautiful building, and then a design engineer and then mechanical engineer too wants to have that challenges every now and then to say, okay, I've got this problem, well, let me solve it, right? That's what we do, engineers. We solve problems. The other method is that we add radiated heat, maybe at the base, on the floor adjacent to the glass, so that you have the hot air that is rising. So fin tube radiation or radiators are used. Sometimes if there is a ceiling available up to 8-9 feet, it's ideal to even put reflecting radiant panels in the ceiling right along the glass.
Kind of heat up that top layer of the glass.
Right, so the downdraft effect is gone. And more ideal is to put a fin tube or a radiator of some sort right at the base of the glass.
And that's something, I guess, as men, we typically wear, we're pretty much always wearing shoes and socks. But I know, especially if women are wearing, dresses, don't have socks on, they're much more likely to feel those cold drafts on their ankles, especially if they have a desk near a window. They're not going to be very happy.
Well, I can't tell you, and in our own office, I've seen some of the female colleagues who cover their legs with blankets in the winter, and while they're sitting. Not always, but when they're sitting for a longer extended period of time on their desks working, they cover. I think almost a few of them I've seen, in our office.
Yeah, or they have little electric space heaters underneath their desk.
And those are the most inefficient things. They're efficient in conversion and energy conversion. Electric things are 100%, almost 100%, there's no losses, but energy bills are don't dictate
It's
that
expensive.
as expensive. So, in certain parts of Northeast here, you can get as high as like a 15 cents per kW. And more you use, on a peak times and whatnot, depends on where you are. Again, you can pay a premium for that type of stuff. It gets expensive.
Yep.
And I think the moral of the story here is that curtain walls look beautiful. There are, of course, today's 21st century's modern style of
we have
architecture.
the technical know-how to make curved glass and to make it blend in with structure. Doesn't mean it's right,
but my argument, and probably yours too, Joe, is that they're not green.
No, definitely not.
If we're going to in a green direction, curtain wall is not green. Curtain wall is expensive. Curtain wall creates expensive problems, and owners are forced to pay for it.
Yep.
They may not understand the implications when they look at an architectural building that's drawn in a SketchUp 3D.
Pretty rendering, and it looks all nice and
Look, everybody wants beautiful buildings. There's nothing wrong with that, right? But people would need to understand that. Look, you can't have a building. It becomes. And Joe, you're an expert in this LEED product. You're a LEED certified professional. We're trying to achieve LEED certifications, which is a topic of another discussion. We should probably have a podcast on LEED, Joe, because that'll be a fun one.
Yes.
You're trying to certify your buildings to LEED, yet you're using all this curtain wall that is counter to what LEED is trying to. So you have to compensate in other places.
I wouldn't say it's contrary to what LEED is doing.
Yeah.
I would say, I think LEED plays right into that kind of game.
Yeah.
But you're right, though. It is. It's not efficient. You create costs. You create additional first cost and operating cost. Not to mention, if someone's sitting there, they're not going to be comfortable, and you'll probably lose productivity costs as well.
Yeah.
And that's, I guess that's the whole point of buildings, is provide somewhere a comfortable environment. And if they're not comfortable, what's the point?
Yeah. Switching gear a little bit. Well, actually, not really. It's actually, let me stick to the topic for a few more minutes. To compensate for some of this, oftentimes you notice that architects have to add vertical fins to compensate for some of the shading, right?
Yep.
And I'm sure that adds money.
Oh yeah.
To a project. But others, one of the things that I was going to mention today, Joe, is what are other solutions that can offset this whole solar gain problem? And you talked about the PV aspect of that. What is it called, Joe?
So I would call it PV integrated glass. It's basically, I know one company I looked up was like Onyx Solar. You can kind of integrate, I guess, all of the materials necessary for PV into glazing, so that I'm sure it provides some solar benefit, some solar control, but then you at least make use of all of this expansive glass, and that you can generate some electricity for it.
Yeah.
It may not be as efficient as, like not having that glass and just putting up a solar panel, but I guess it could be kind of a compromise of having all that glass and getting some benefit out of it. But I know when you mentioned the fins, one thing I would like to add to that, like typically, at least here, for your south-facing glass, you would put like an overhang so that you do get some shading direct, like noontime sun. And then for your like east and west glass, that's when you would put your fins, so you can kind of get some of that morning shade and your afternoon shade. I know a typical way, at least for like your overhangs, because in the summer, your sun is more like directly down, and then in the winter, you have a lower sun. So you look at like your summer solstice to get your sun angle in June, I believe, then your winter solstice to get where your low hanging angle is. And so you kind of provide your shade, so you're not going to block that winter sun, but you are going to block that summer sun. So you can kind of make your design like a roof overhang or something like that to maximize your summer shading, but then also maximize your winter sun, so you get that like passive solar gain. Of course, if you don't have an overhang, that's when you overheat and you have to run your cooling in the winter time,
Yeah,
which is a silly thing as well.
that is a silly thing as well. I understand that sometimes you have a building that has a lot of external, but in a lot of internal as well.
Yeah.
You need cooling all year long
Yeah.
for those buildings, but so shed more light on that PV integrated glass. I used to know this product called Konarka, and apparently they went out of business.
Yeah.
But Konarka, Konarka, used to be, and you can still look up the images, used to make this little peel and paste sort of film that could go on pretty much any surface. They even had handbags for, men and women to have something right on there, and you're walking about and it's charging stuff, right? And I think that stuff still exists, but they could be applied on glass. They could be applied on any like roof of your car, things like that.
I've seen people with backpacks that have like little solar panels on it.
Yeah,
Probably when you charge your phone or something like that. when
Yeah.
you walk around.
yeah, but those usually are a little bulkier and they're not like peel and stick.
No,
No.
yeah, integrated in.
Yeah, but Konarka, so and then in the windows too, like now that we're seeing a lot of use of double pane and triple pane windows. And do you want to go into what does
Sure.
that mean? What is a single, double, triple pane? Is it like
So
Go ahead.
your typical, I guess, like older windows, it's all single pane. So pane, you might hear it referred to as like a light of glass. It's like LITE, and it's just, especially old windows, literally just one piece of glass with maybe caulk around it or something like that, and a wood frame. Then they have, double pane glass, which you have your two pieces of glass with kind of like a spacer around it,
and
and then that
is that an air gap?
interior- Yeah. So
Yeah.
usually air is probably the cheapest. Then they will do argon.
Argon, yeah.
And then Krypton is another one. I
Mm-hmm.
think the Krypton is more expensive to get, so it's more pricey.
Pricey, yeah.
But it's a better thermal performance than that. So it doesn't-
Well, my understanding was it wasn't a whole lot of difference.
I don't think it's a huge
Yeah, it was a minor difference,
minor,
but that's why people stuck with argon instead of.
yeah.
So, all right.
cheaper.
What about the third?
And triple, they just add another pane of glass and then
Another air gap.
Yeah.
Yeah.
And
yeah.
so that's where, I mean, you can get, who knows, you probably, so like single pane, I guess a typical like U value for that is 1,
Mm-hmm.
and then the solar heat gain is 1. It's kind of like a reference. So then you go to the double, you can easily cut your U factor. Nowadays you can get into the 0.3s, easily 0.4 or so for your heat transmittance. And then with your triples, you can get that like 0.2s. I've seen some that will be like a 0.15, which is like relatively, that's kind of a not good wall performance value. So you can, I guess to put it in perspective, you can have like the most amazing glass is comparable to a not good wall, like insulated wall, but not up to current standards. Maybe like a 1990s or older home would probably have a wall similar insulation to that.
Yeah.
And especially now with glass, they have like low E films, which is like a low emissivity film. And what it does, it'll block your solar radiation. So it might either reflect it back outside, or it can also kind of, depends on where you put it. You can work it so you might reflect some out, but you can also put it on the inside so it will keep heat in. Depends on what you want to try to do. But with the technology, you can get glass that you could stand next to it on a cold winter day and you won't feel that cold. It'll be
Right, because of
sort
that
of
air
roomish.
gap or the gas fill gap.
Yeah, that's your like triple
Yeah.
pane.
Yeah.
Expensive. It's definitely
It's very expensive.
very expensive.
Yeah.
But that's maybe
Double is relatively, because it's adapted so much
Yeah.
now that even in residential the price of windows have come down.
Yep.
And is it a true statement to make that for the curtain walls you can get the same systems?
Yeah.
Yeah.
You can double, triple. There's a thing with the curtain wall too and all that. You'll hear of thermal breaks, which it basically means in your metal frame
Right.
there's either like a plastic or some
Rubber or something.
yeah,
Yeah.
and it stops that heat transfer,
Heat transfer. Yeah.
going directly from your outside,
Outside
to
to
your
the
inside.
Yeah, and then structural people, like in a commercial and industrial buildings, structural engineers have to use that often if they're steel, if they have cantilevers or like overhangs that are extending beyond the building
Yeah.
externally. Then when that steel is trying to connect to a steel that's internal to the building, they have to have thermal breaks. And there are a couple of reasons. One is that you don't want the cold to transfer inside primarily, and the other part is the condensation part of it. So you have that thermal break so that you're not condensing on the steel and creating rust and so forth.
Yeah, that could be a very bad structural problem if you.
That's right.
Yeah.
And especially in the long run, like the corrosive environment. So like if you're closer to the ocean, you have special coatings on external steel anyway, but internally it could also impact. And often like in buildings like natatoriums, pools, right, where it's very corrosive. There's a lot of chemical use, so you want to be. Condensation is a very big element in buildings of that types where there's a lot of humidity internal to the building, and the adjacent spaces where the buildings are much cooler, because pool spaces are not very cold. They're warmer. They're hot.
Hot and humid.
They're hot and humid, and so if they're adjacent to, and I'll give you a quick example of a problem that we've had in my lifetime career, where there was an ice rink, indoor ice rink, and directly above it was a air conditioned.
Heated and ventilated, right?
Heated and ventilated. Yes, it was, and it was a athletic field. It was called Field House, and had a running track, basketball, type of activities up there, and it was just ventilation air, and even the ventilation air was not like conditioned to. It was just almost, there was no chill water coil to dehumidify at all, so it was just brought in raw. So raw air was coming in, and when there's ice in the ice rink, and the ice rink temperatures and dew point temperature is maintained. I can't remember exactly what dew point temperature is usually maintained in ice rinks, but it's very low. The contact surface between the floor itself, because the field house was directly above it, much warmer and humid, started to condense, and it was condensing so much that there was pools of water on that floor. And so there is those implications. I think we're getting off the topic here, but just the complications that there are with buildings.
Yep.
So I think that you'd mentioned. Oh yeah. So one of the things that I want to talk to you about is we talked about the PV integrated glass.
Yeah.
And that I'm sure that there's an opportunity to integrate that into the curtain wall systems that architects love so much.
There is a whole, I forget what it's called, but yeah, basically like integrating PV into buildings. It's kind of, I don't know if it's going to pick up as a design strategy, but kind of, I guess, because right now people do like having electric buildings, and so why not generate some of your own power? So even if you have like just PV panels on your exterior walls hanging there, or you do like a PV integrated into your glass to maintain whatever kind of exterior aesthetics you're looking for.
Well, my fear, Joe, is that the owner is already paying for a massive glass, right? Double pane, triple pane curtain wall system, and then now you're adding.
It's more cost.
Yeah, you're adding more money to it by adding PV to this, right? I'm sure that's very expensive, because solar is, as much as it's subsidized already, right? It's still very expensive, and I'm not even sure if you get some incentives back. I'm sure you do somehow if you can qualify for, I don't know.
I know the state south of us has a lot of incentives for us.
I like the way you put it, man. State south of us. We're in New Hampshire, folks.
Yeah.
We're live free and die, baby.
So Massachusetts is all about electric right now.
Yeah.
Yeah.
So there are some advantages, welfare advantages, I
Oh,
should
yeah.
say. Everybody wants to be a welfare queen around here
Yeah.
or around there.
But there's actually, I forgot to mention, there's another kind of strategy to deal with. There's a couple to deal with all your glazing.
Yes.
One of them, now they have like vacuum insulated glazing systems.
I'm glad you mentioned that because I almost
Yeah.
forgot.
it's I think it's just taking off, not even taking off. It's kind of it's been about for a few years. Very limited commercial, residential availability. But the idea is that you take, your 2 panes of glass and you make it a vacuum in between. And by making a vacuum, you kind of eliminate a lot of the heat transfer that typically takes place. So like in a vacuum, you don't have your convection because you don't really have any air that's going to be moving around it. I think so. That's one of the main heat transfers from it. So you can basically get like a double pane glass with the performance of a ultra good triple pane system. And what I've seen, there's a company in England that does it, and they're going for the remodel market where you would go from like a single pane of glass, which is pretty thin, and they have this vacuum insulated panel that can, like, architecturally and pretty feasibly fit into that. I mean, maybe it's slightly wider, but you can use your same windows and maybe same frames and just slight modifications, put it in, and you won't know the difference aesthetically, but you will see a lot of like heating
Improvement.
and cooling savings.
Yeah. I'm curious because I'm curious about the pricing of these things. I'm hoping that it sort of, picks up a little more in United States and whatnot. But the one of the criticisms, and you or I are gonna probably see a lot of emails after this episode, Joe, where people are gonna say, "Oh, you guys are nuts because these windows are awful because of building, they're building movement, and there's a lot of leakage problems with these. So you have all this air gaps, but then." Over time the seals break because they're not kidding. That is true. That happens and with expansion and contraction. 5 years down the road, how do you know that the argon gas is still in there or vacuum is still intact?
The only way you probably know is just by sitting next
to it.
If you
And
feel cold on like a 10 degree below day, something is not working anymore.
Here in Northeast, a lot of people use propane or natural gas or even oil, type 2 oil, which is almost diesel, or maybe there is other forms of hydrocarbons that people use too. But if your if your energy bill is going up, something's up.
Yeah, you can easily. That's a good point. You could track it year to year.
I suppose there's a question for the manufacturers too, like if there's a method to test these things.
I don't know.
Yeah.
It seems, I guess besides just sitting there and...
there's probably, if there's no more vacuum, right? Then do you think that... that's a very good physics question, actually. I can't recall, Joe, but I should have looked that up before the episode. Is that space negative to its atmosphere, or is it positive to its atmosphere?
It has to be negative because I have
nothing
in there. So if you have a hole, it's going to
suck in, right?
Fill it
so
right
you
up.
Probably could maybe do a test of some sort where you have a heavy smog or smoke that you're introduce around it and see if it is sucking from anywhere.
Something, like maybe denser than air.
Yeah.
It would fill up that airspace.
Yeah. That does make sense. Yeah.
There's another technology out there too, more for the solar control, and it's called. You can have like kind of dynamic glazing or like electrochromatic glazing. You put like, I think some of them use like ceramic films, but you have very very thin films on your glazing, and then you can apply a voltage to it to make your clear glass go dark.
Yes, right.
And so it's kind of. It's a very neat idea. It's obviously.
Does it reflect?
Ways. I think it, I guess so, somewhat, yeah.
So you improve on the solar gain.
Yeah.
Not necessarily on your convection in the winter, but at least on the heating season.
Gain,
yeah. And typically for our audience, it's the cooling the building is more expensive than heating, because heating can be accomplished with hot water hydronic methods.
Yeah.
and those are relatively like it's cheaper to move water than it is to significantly cheaper to move water around than it is to move air around.
Plus, at least in the winter, that sun offsets some of your heating loss. So you kind of like you want that sun in the winter,
That's right.
but in the summer, everything that the window, I mean, except for the daylight part.
Daylight part, yeah.
Besides that, the window.
Well, LEDs
doubles.
have fixed that problem.
Very, very cheap. Yeah.
Yeah,
Cheap
LEDs
lights.
and you know like the and they're automatic. Like if you have a proper control system, then LED respond to the daylight,
Mm-hmm.
so they dim as they need to, which is pretty incredible.
It is. It's fascinating systems if they play together right. It can be very efficient and very comfortable.
Mm-hmm.
But if they don't, it's a very expensive.
It's expensive.
Could be very annoying if your lights are going on, off, and
Yeah.
all that.
How do you feel about Tesla's roof
Their,
shingles?
I think it's a neat idea trying to make something that's, well, now I don't think people mind having solar panels on the roof. I think people almost enjoy displaying their solar panels, but I could see like before, if you could kind of integrate solar onto your roof and, it looks really hidden and pretty sly, it was great, very good. But I don't really know if it's, I would almost say like they kind of lost their time. I mean,
I have yet to see right here in my town where there's so much lakefront property.
yeah.
I've yet to see a lakefront
It's
$1 million
true with,
house with solar panels on it.
Yeah.
They don't care, man. They
they-
don't want their house to look ugly.
Especially if they're only here in the summertime, they probably don't.
Well, my town mostly is all
Year
year.
round.
Yeah,
Okay.
no, you're probably right. About 20-25% is summer people. There's some corporate homes here too, but
So I mean, I
No.
guess, for them, it's probably no, unless if, I guess maybe that's when the Tesla
well,
comes
energy is
in.
cheap here
Yeah.
in New Hampshire compared to Massachusetts. I pay, I think it's a 6 cents or between 6 and 7 cents per kilowatt.
That's cheap.
That's almost half of, but to a certain kilowatt. After I cross that barrier, then that bumps to 9 cents.
Sure, I'm sure those homes are probably very intense energy and
Yeah.
they probably have
Well,
air
unless they're
conditioning
passive homes,
everywhere.
right? Unless they're passive homes, we don't know that,
Yeah.
right? From the outside, they all look the same,
Yeah.
right? Although they have like a lot of glass and stuff, so I would be surprised if. So, thing about people with
Hot
money
tubs
is
and TVs in every room.
Right,
and-
right. Yeah, I mean, not that nothing wrong with that, but thing with rich people is they like glass.
They can
They-
afford it, right?
If they're gonna
can
live
have
on the
nice-
lakefront or an ocean front, they want glass. That's why they're there. They
Mhm.
want to be, even when they're outside, perfect. When they're inside, they want to see water. They
wanna
want to
look
see the
out.
green. They want to see these beautiful white mountains.
Mhm. Or they want to watch the storms come in from their comfort of their living room.
That's right.
It's
you know, They
there's
all have
a lot of good parts about it.
right. We have no natural gas in this town, so they all have, probably propane or oil-fired boilers and systems like that, heat pumps maybe even, and they all probably have, very likely, all have wood stoves so that they can enjoy that hearth
Yeah. That
feeling.
radiant heat, you get a little
Right?
fire crackling in the nighttime.
Yeah, every lakefront home here around here, most of them anyways, have
Little-
chimneys sticking out.
Oh yeah,
So there's that.
it's nice. I would have a wood stove if I could.
Yeah. We should have a podcast on wood stove one day.
Mhm.
Talk a little bit about more that technology, where that's going.
Yeah.
With the EPA hammering down on it, taking some more of your freedoms away, but we'll get into that. So if I don't know if I have anything else to conclude this podcast, Joe, you've been running your mouth since
There was
1
one-
hour and 10 minutes already.
not bad. One thing I saw today when I was looking up the vacuum insulated glass that kind of blew my mind, and it was this company. It was advertising that they had DOE compliant like glass for your like refrigerated coolers and stuff like that, and DOE being Department of Energy. I just thought it was funny that the government is kind of regulating the glass probably for supermarkets too, you know, like that glass that's in your refrigerated aisles and freezer aisles is regulated, and it's gonna
Why?
have, I mean, I can see the point is you could, I mean, by a supermarket's interest, it's a giant energy waste if they are losing all of their cooling to the aisles. But I just thought it was kind of a funny thing for the government to regulate.
Interesting.
Yeah,
Yeah.
the
Wow.
government's everywhere.
But baffles my mind.
Yeah.
I mean, I get it, you know, like their energy savings are important, but then, you know, fresh vegetables are more important.
Yeah.
So,
But I like to have my Ben & Jerry's ice cream nice and cold, and I don't want that freezer burn too. So
right.
if it keeps it, you know, nice and cold, but
Yeah.
not dried out.
Not dried out. Yeah. Mm-hmm. Yeah, absolutely. So, Joe, I think on that note, we're going to wrap it up here because it's gone longer than we anticipated. I was going to say, again, dear architects,
Enough for the glass.
that's right. And please start designing your buildings to maybe something more creative, similar to
Yeah.
the Philadelphia Town Hall or Eisenhower
Yeah, be creative out there.
executive office building.
Use your imagination a little bit.
Well, they do, but it's just they're after a new trend, and
Mm-hmm.
it's very costly. It's not green. It's not effective. It's it costs a lot of money, and we think that it's time we have a honest discussion about these things. So thank you very much for listening.
Yeah, I'll see you next time.
Bye.
Please subscribe to us via iTunes, Stitcher, Google Music, and YouTube. And visit us on engineering.tech. This was Engineering Tech Show.